Hello, my name is Harry Styles and I'm so grateful to be a host for SNL tonight. Tonight I'm here to promote my new album, Harry's House, but we have a plot twist. For this new season, we have asked teachers across America to choose a theme for the evening. We've chosen Miss Barker from Long Beach Polytechnic High School. Our theme is basic differentiation rules. This is the part where you clap. We'll explain it later. Our musical guest is Althea aguel. Apparently, she started off as a fan of mine. I didn't know that something you can buy in IKEA can play guitar. We have got a great show for you tonight. Enjoy!
Hello, I'm Peppa Pig, and today I'll be discussing a few of the basics of derivatives. First, let's start off with the derivative of a constant. Now, let's see if any of you know what the derivative of a constant is. Yes, Harry?
0.
Correct. Now, let's move on to the power rule. To find the derivative of a function, we put the exponent in front of the function and multiply it with the coefficient. That equals the new coefficient for the derivative. Then we subtract 1 from the exponent of the derivative, and that will be the new exponent for the derivative. Let's try an example. Here the function equals x to the third plus 5x plus 8. To find the derivative, let's use the power rule. So we're going to see the 3 and we're going to add it to the coefficient. Then we're going to look at the exponent and minus 1 from it. So that would be 2. Then for this, the exponent times the coefficient would be 5, because 5 times 1. And then it would be x. So then the exponent of 1 minus 1 equals 0. And that would be x to the 0. Therefore, we wouldn't see the x, because there would be no more x. Lastly, for the constant, that would always have a derivative of 0. So, for our derivative, it will be 3x squared plus 5. The constant multiple rule basically says that as long as the constant is a real number, when it is multiplied by a function, it is equivalent to the constant multiplied by the derivative. Lastly, we must talk about the sum and difference rules. That means that f plus or minus g is equivalent to the derivative of x plus or minus the derivative of g. Super simple. Any questions? Yes, Harry?
What's your favourite track on Harry's House?
I'd have to say grape juice. However, I am upset that you never wrote a song about Mr. Potato.
Aha, good choice. Maybe on the next album.
See ya!
Max Mayfield, I have a huge secret to tell you. In order to save yourself from vecna, you need to know the derivative of sine and cosine. The derivative of sine is cosine x, and the derivative of cosine x is negative sine. Make sure you know that. I have to go.
Now here's Althea singing her hit song, How to Find Where Functions Have a Horizontal Tangent Line.
Today I'm gonna teach you how to find where functions have horizontal tangent lines. It's pretty simple. You just find the derivative and set it equal to 0. Then you solve for x, and you'll find the answer. But then you'll be put to the test when you have to learn this for calculus. This is how to solve for where functions have horizontal tangent lines. It has many uses in calculus. In the best we will do an example for you. That this is how you this equation and find the derivative by using the power rule. Look at x squared. We multiply the 2 by 2 and that equals 4. That's our new coefficient. Subtract 1 from 2 and that equals 1. That's the new exponent. We're almost done. This is how to solve for where functions have horizontal tangent lines. It has many uses in calculus, and up next we will find the derivative of 5 and have a great time. Now on to 5. Well, 5 is a constant, and something we have to remember is that for constants, their derivatives always equal 0. We will move to the next part. It'll be so exciting. Calculus is so much fun, and Miss Baka is thriving. This is how to solve for where functions have horizontal tangent lines. It has many uses in calculus, and up next we'll say the derivative to 0, and now we'll solve for it. We divide both sides by 4, which equals x equals 0 over 4. That equals 0. So x equals 0. Our horizontal tangent line is that way. The function equals 0. This is how to solve for where functions have horizontal tangent lines. It has many uses in calculus. In calculus. In calculus.
Now that was our show. I hope you all enjoyed it. Have a great night.